April 18, 2026. 20 states, and most people had 30 minutes notice. That's not a failure of the forecast. That's exactly how Aurora prediction works. And the reason why is stranger than most people expect. On the night of April 18 into April 19, 2026, NOAA's Space Weather Prediction Center issued an Aurora forecast covering a sweep of northern US states from New York to Idaho, stretching across the upper Midwest. 20 states. Potentially visible northern lights on a Saturday night for anyone willing to step outside and look up. It wasn't even the first alert that week. A G2 geomagnetic storm had already given the northern United States a shot at the Aurora on April 17. 2 nights in a row. The kind of back-to-back window that Aurora hunters wait months for. The question most people never think to ask: how do scientists even know this is coming? The answer starts 93 million miles away, on the surface of the sun. The sun rotates on its axis once every 27 to 28 days, as seen from Earth. That's a predictable cycle. And it's the foundation of one of Aurora Science's most useful tools, the 27-day Aurora forecast. The logic is elegant. Active regions on the sun, the areas most likely to fire off the solar wind streams that trigger geomagnetic storms, tend to rotate back into Earth-facing position roughly every 27 days. If a region caused a storm this week, there's a meaningful chance it'll be pointed at Earth again in about 4 weeks. Aurora hunters use this. Scientists use this. It's not a guarantee. The sun is chaotic and active regions can intensify, decay, or disappear entirely during that rotation. But it gives forecasters a baseline, a look ahead built not on guesswork, but on the geometry of our own solar system. That long-range view is only one piece of the toolkit. Long-range forecasts tell you when to be ready. The 30-minute forecast tells you when to go outside. NOAA's Aurora 30-minute forecast is built on something called the ovation model. It takes real-time solar wind data and translates it into a prediction of where the aurora will appear and how intense it will be in the next 30 to 90 minutes. The Space Weather Prediction Center also runs an experimental Aurora viewline product, which maps the predicted aurora boundary over North America for tonight and tomorrow night. 30 minutes, that's the window. Not days, not hours. 30 minutes between the data looks promising and go stand in a field right now. This is why aurora chasing has a reputation for being equal parts science and scramble. You can plan for weeks using the 27-day cycle. You can narrow it down to a night using storm alerts. But the final call, the moment you grab your jacket and run for a dark sky, comes down to a model that's updating constantly. For the April 18 event, that model was pointing as far south as the upper Midwest and the northern tier of states from New York to Idaho. Meanwhile, the University of Alaska Fairbanks Geophysical Institute was forecasting something far more routine: low aurora activity, with low-level displays potentially visible overhead from Utqiagvik to Fairbanks. That contrast tells you something important. For communities in Alaska's far north, a night with low aurora activity is still a night where the lights might be overhead. Utqiagvik, the northernmost city in the United States, sits so deep inside the auroral oval that the northern lights are less a rare event and more a seasonal fixture. For the rest of the country, a G2 storm is a news headline. For Fairbanks, it's a Tuesday. The auroral oval is a permanent ring of activity encircling the magnetic poles. It expands during strong geomagnetic storms, which is exactly why a G2 event can push visibility down into New York and Idaho. On quiet nights, it contracts back toward the poles, and Alaska's northern communities remain inside it almost by default. Most people think of the northern lights as something wild and unpredictable, a natural phenomenon you either stumble into or miss entirely. The real picture is different. NOAA's Space Weather Prediction Center is running continuous forecasts, experimental viewline products, and near real-time storm alerts, specifically so that a Saturday night in New York or Idaho doesn't have to be a mystery. 3 systems working simultaneously: a 27-day solar rotation cycle, a G2 storm that expanded the auroral oval far enough south to cover 20 states, and a 30 to 90-minute model that told people exactly when to step outside. The aurora is still nature, but now at least it texts you first. If you want to know when the next window opens, and how to actually use the forecast before it closes, the full breakdown is at factstormhub.com. Subscribe for more stories like this, and we'll see you in the next one.